Hi, this is Matt Dirjish. We're here at Sensors Expo 2015 in Long Beach, California. I'm sitting here with John Austin. He's Product Marketing Manager for Analog and Integrated Products. And today we have a very interesting device. It's the world's first integrated thermocouple electromotive force to degrees Celsius converter from Microchip. John, could you tell us a little bit about this chip in terms of how this is, what is so important about it being the first plug-and-play type device of this nature?
Yeah, so thermocouples are fairly complicated systems to design an accurate solution for. They require precision instrumentation to sense microvolt level signals. It requires precision analog to digital conversion, so you need a mixed signal expert to develop that system. Thermocouples require the ability to do complex math equations to convert those small voltages into a corresponding temperature. So there's a lot of things in play. Requires a lot of expertise to develop an accurate thermocouple solution. So what we did was we integrated all that into one device. We have a lot of internal IP for precision analog and mixed signal components. So we integrated the precision instrumentation. We integrated the cold junction compensation with the precision temp sensor. We integrated the high resolution data conversion, and then we also integrated the math engine along with all the firmware for the basic thermocouple types, K, J, T, N, S, E, B, and R. And those are all standard thermocouples you can find in the market today.
From what I understand, this is a very robust device that can handle like a variety of environments, usually pretty harsh in some cases. For say a typical maybe K-type thermocouple, what would be the upper and upper and lower extremes of temperature that you would be working with?
Yeah, I mean, so I can't remember the specifics for a K-type. I mean, if I were to take a wild guess, it's somewhere around -200 C to 1800 C or 1200 C.
Yeah. Or a thermocouple that you're familiar with too.
If you look at all the thermocouples or the standard ones, I mean, you're looking at temperature ranges of anywhere from -450 or 500 degrees C all the way up to 2500 degrees C, depending on the thermocouple you choose. And that is just standard thermocouples. There are also special thermocouples that people develop to give them different characteristics for different temperatures. Yeah.
Well, being so versatile and handling quite a number of different thermocouples, I guess this is a lot of target industries that you can go with this. And just name a couple off the top that would probably be the most popular, that people would run to the door and say, I need this,
Well, thermocouples are used, it's a very common thing used in a lot of different applications.
Sure.
So if you think of anything with extreme temperatures, or a rugged environment, I mean, typically people will use a thermocouple. So common places, water heater for a consumer or an oven would use a thermocouple. You can look on in industrial for like boilers, right, would use thermocouples. Petrochemical applications use thermocouples.
Yeah,
I mean, it's as far as a temp sensing solution, it's probably the most common.
Excellent. So you got all the bases covered in there. I understand you also have a demo board that people can buy and test it out with. Do you have a little demo you could show us how this works a bit?
I do, absolutely. So this is the MCP 9600 demo board. You can see the MCP 9600 right here. It's in a 5x5 QFN package. One thing to note is that there's no passive components. I mean, really the only thing on the board is the microcontroller and the 9600, and then you have a connector for the thermocouple. The board comes with a K-type thermocouple, so I'm going to go ahead and plug that in. And then if you look on the GUI, right here is where you would select the thermocouple type. K is selected, but it has all the other options available. If I want to do just a single update, I can click the Update Sample button, and it gives me a temperature reading over here in the registers. You can see the hot junction temperature, which would be the thermocouple. You can see the cold junction temperature, which would be the temp sensor on the device, the integrated temp sensor. And then it gives you the calculation of the hot junction minus the cold junction, so the delta between the two. And then it also gives you the measured value of the thermocouple in millivolts. So it gives you that value as well. And then the rest of the registers, like the status register, the sensor configuration, and the device configuration, really they relate to the different features that you can set up in the GUI. So for the demo, I'm not really going to go through those. But things to note is that you can set up the shutdown modes in here. We kind of talked about that during the presentation. You can set the resolution for both the hot junction and the cold junction, as those are, as I mentioned, programmable. And then you can also set up the filter in here under this tab. So up here in the upper left, there is a button that will allow the part to data log the temperature readings for both the hot and the cold junction. The hot is the red, and the cold junction is the blue, so the thermocouple is the red, and the internal temp sensor is the blue. So if I add heat to the thermocouple temperature, you can see it rising. And if I let it go, it should go back down. Excellent. And then down here in the bottom, you have all the features that we kind of discussed as far as the alert limits and things like that. So if I click on the binary register, you can see, I'll do alert 1 so you can see the change. But if you look at the alert 1, it's all zeros. If I enable, it turns it to 1. So I can enable all the different alert features. I can set the thermocouple or the cold junction as the reference temperature. And I can change the rising and the falling edge. I can select between the two. The rising edge corresponds to an over temperature condition. The falling edge, under temperature condition. I can change the polarity from active high to active low. And I can change it from a comparator to an interrupt. And then I can set my limits and my temperature hysteresis down here on the bottom. And so that is basically the thermocouple demo board.
That was a great demo, John. Kind of question here, with the level of integration in this particular device, you probably eliminate a lot of discrete devices and save a lot of money that way. About how many offhand?
I mean, a typical discrete solution can have upwards of 15 components, and you can service that with one device.
So that takes a big chunk out of the price of the end product.
Right, and board space savings as well.
Oh, yeah, that's always important. So that speaking of price, so what does this little wonder cost then?
$3.54 is what it is on the website in 5K volumes.
Excellent. So how would that compare to, say, a comparable device out there?
Discrete solutions for just signal conditioning, they can vary up to $10 just for the signal conditioning.
Yeah, so basically you're raising it down by a little less than a quarter. That's
right.
Great.
Yeah.
Well, listen, thank you very much for a wonderful demo, and I wish you a lot of luck with the new product. I'm sure it's going to do well.
Great. Thank you.
Thank you.